Welcome back to the deep dive. Our mission today is pretty laser focused. We're aiming to provide the definitive shortcut for application developers navigating the new Gemini ecosystem.
That's right.
You've all submitted your sources, the technical reports, the developer docs, everything right up to December 2025. And we are here to distill the most vital information you need to build faster, smarter, and hopefully with fewer headaches.
I think that's the key, right? Fewer headaches, because we're seeing the same questions pop up over and over again.
Exactly. So this deep dive is really tailored for you, the learner, the builder, who's grappling with those common frustrations. Things like, why is my API quota suddenly unavailable even though I just paid?
Oh, that's a huge one. That and, which model should I actually use for my trivia app? Is pro overkill.
Yes. And the big one, how do I turn this large language model from a cool toy into a truly reliable agent that can actually do things?
And we're going to cut straight through the noise on that. All those core questions, they all really point to the same fundamental journey, the shift from simple prototyping to scaled, reliable production. You need to cover model selection, migration pitfalls, and the advanced tooling that really dictates performance, like function calling.
Okay, let's unpack this then, because the revolutionary takeaway from all these sources, when you boil it all down, is really twofold. And it fundamentally changes how applications are even architected.
Right.
First, the context window size has made it's a generational leap. We are talking about millions of tokens. This completely changes how you handle massive data sets.
It's a paradigm shift.
Yeah, absolutely. And second, the agentic capabilities. The stuff driven by advanced tool use and just better reasoning, it's transforming these LLMs from just being chat interfaces into actual operational systems.
Yeah.
And we'll be hitting those common developer pain points, access pricing, feature reliability as we go.
Sounds like a plan.
All right, segment one. Let's start with the absolute foundation, the development environments. For anyone just starting out in the Google ecosystem, you're probably beginning in Google AI Studio.
Almost certainly.
Our sources really stress that mastering the 4 core interaction modes in the studio basically defines mastery of the platform itself. So, what are these modes and what kind of journey do they represent for a builder?
Well, the modes are really designed to address different use cases right out of the box. You start with the 2 core conversation modes, which is where most people get their feet wet.
Okay.
First, there's chat. It's the classic multi-turn conversation space. It's your standard sandbox for, testing basic prompts, seeing how the model behaves in an ongoing dialogue is exactly what you'd think it is.
It's a back and forth.
Exactly. But then, right next to it, you have Stream. And this is where things get a bit more interesting. It's optimized specifically for real-time, low-latency conversation.
So if I'm building, say, a voice agent or some kind of live assistant, Stream is where I'd go.
That's the perfect use case. If you're building any dynamic interface where quick, continuous responses are paramount, Stream is the mode you have to use. It makes the interaction feel immediate, not like you're waiting for a server.
Okay, so we've got text, but then we move beyond just text and dive into the creative capabilities that are, they're becoming multimodal standards everywhere. The third mode is generate media.
Right, and this is where the platform's power really starts to show. The sources list some specific models here, and it confirms just how broad this creative suite is. You've got VO2, 3, and 3.1 listed for video and audio generation.
So we're not just talking about generating images, we're talking about complex, time-based media output.
We are. And this addresses one of those common developer questions we see, where someone says, hey, I can't generate video using VO2. What's wrong? Well, the capability is right here in this mode. It shows the platform is built for it.
And there's another fascinating mention in the sources, a model called Nana or Banana.
Yeah, that one's interesting. It's listed explicitly for CV photography generation.
CV as in computer vision.
Computer vision, exactly. It suggests that even these highly specialized niche tasks are being democratized through natural language input right inside the studio. You don't need to be a computer vision expert anymore to get started.
That's incredible. But for an application builder who needs to deploy something fast, the real magic is in the 4th mode, isn't it? Build mode.
This is the game changer for rapid deployment. It's essentially the no-code or maybe low-code environment where you can build an entire working application scaffold just by dropping in a natural language prompt.
And then you can just deploy it to a URL.
Instantly. You can deploy it to a shareable URL right from the studio. It's designed to get you from an idea to a working prototype in minutes, not days.
Okay, you said build mode is powerful. Give me a real example. How fast can I actually deploy something with this? Are we talking about just some boilerplate code or a truly functional app?
No, it's surprisingly functional. The sources reference that famous example that's been floating around, building a fun with flags guessing game. You literally just prompt build mode with the idea,
Yeah.
build me a game where you show a flag and I have to guess the country. The studio then breaks that large task down into smaller, digestible steps. It might generate the app structure, the prompt template for the model, even a basic interface code scaffold, all in real time.
And you can see this happening.
You see it happen. And crucially, you can test it immediately in the preview mode. Then you can keep iterating, again, just using natural language. If you decide you want to add a scoreboard called, I don't know, correctum flaggerum,
A very distinguished name.
a very distinguished name, you just tell the model, add a scoreboard with this name,
Yeah.
and it integrates that functionality right away. It's an incredibly fast way to move from concept to a shareable MVP.
That ability to prototype and iterate so quickly is essential. But as any app grows, controlling the model's identity, its personality, becomes just as important. This is where system instructions come in.
Right. System instructions are the core mechanism you use to tailor the model's behavior, its tone, its constraints. This is how you make sure the application experience is consistent and aligned with your brand or the task at hand.
So if I'm building, say, a legal assistant, I would use system instructions to tell it to use formal, non-speculative language and to cite sources for every single claim it makes.
Perfect example. Or you could do what the documentation does and create Tim, an alien on Europa.
I saw that one. You define his entire persona, you instruct him to adopt a chipper, upbeat tone, and you constrain his output, maybe keep every answer under 3 paragraphs. It sounds like the perfect way to nail the user experience.
It is powerful for consistency, and here's where we hit a really significant developer pain point, one that often shows up as those mysterious API and billing issues. This is the hidden cost of consistency.
What do you mean?
What's absolutely critical for developers to realize is that every single message in the chat history, and this includes those initial system instructions, is included in the prompt for every single turn.
Wait, hold on. So if I spent a lot of time crafting that perfect system instruction for Tim, the alien, and he's designed to answer questions all day, I'm running up my token bill just by having him be himself.
Precisely. If Tim's persona description is 500 tokens long, those 500 tokens are included in the input prompt for every single interaction, every question the user asks.
Wow.
So this means conversational prompts will grow long very, very quickly.
Yeah.
If your application handles long, multi-turn conversations, you are constantly eating into your input token limits.
And that directly connects to those developer complaints about API key quota unavailable. The problem might not be their billing or their key at all.
Often it's not. The problem is that their application is hitting token limits much faster than they ever anticipated because of the cumulative size of the conversational history and those system instructions. So optimization in this case means relentlessly minimizing the size of those repeated inputs. It's a fundamental architectural concern.
That is a fantastic practical tip for managing costs right inside the studio. But okay, as soon as a developer finds some success, they need to migrate. They need to move from the playground to a serious production setup.
Inevitably.
Our sources clearly lay out that development often starts in AI Studio, but serious production deployment almost always moves to Vertex AI. Why is that migration so necessary?
Vertex AI provides the critical enterprise-grade environment that you just need for scaling a reliable application. I mean, AI Studio is fantastic for rapid prototyping and generating code, but before you can move to true production, you have to consider so much more.
Like security.
InfoSec, definitely, but also governance structures, achieving regulatory approvals, which is absolutely vital in regulated sectors like finance or healthcare, and ensuring geographical location availability for things like data sovereignty. Vertex AI gives you all the necessary control and compliance infrastructure that AI Studio as a prototyping tool simply doesn't offer.
So Vertex AI is really about long-term stability and mitigating risk, but even stable environments face, well, fundamental sunset risks, right?
They do.
This brings us to a major point that developers absolutely have to manage: model retirement dates. What are the hard deadlines we need to put on our calendars right now?
Okay, this is a crucial operational risk that requires proactive planning, especially if you have anything in production. The most immediate deadlines are for the older 1.5 models.
The ones that introduce the long context?
Right. If you're relying on that powerful long context but haven't yet moved to the newer 2.5 architecture, you need to be warned. Gemini 1.5 Pro and 1.5 Flash are both scheduled for retirement on September 24, 2025.
Wow. Okay, that's less than a year away from when this material is published.
It is. It means if you're deploying a critical revenue-generating application today using 1.5 Pro, you have less than 9 months of a guaranteed runway. That forces an immediate re-architecture decision. It's not something you can put off.
That is a very tight window for any kind of enterprise-level migration, so the newer models give you more breathing room.
A bit more, yes. The Gemini 2.5 Pro and Flash models have later retirement dates, like June 17, 2026. This staggered schedule really emphasizes that migration isn't a one-time event, it's an ongoing cycle of operational management you have to build into your process.
And that operational risk, that ties directly into how developers manage their budget and their capacity. This leads to another huge set of popular questions we see: pricing, and specifically managing guaranteed capacity. The documentation highlights a concept called provisioned throughput.
Yeah.
Can you define what that is and why it introduces a whole new layer of complexity?
Absolutely. This is where you move from pay-as-you-go to enterprise-grade capacity management. Provision throughput is essentially when you pay to guarantee a dedicated minimum capacity slice for your application.
So instead of sharing a pool of resources, I'm buying my own private lane on the highway.
That's a perfect analogy. You're not relying on the standard pay-as-you-go limits that can fluctuate based on overall system load. If your application requires low, consistent latency and a minimum throughput, say, handling 100 requests per second at peak, you provision that capacity. You pay for that guarantee.
So it's about stability and getting performance guarantees, not just trying to avoid a high bill.
Exactly. It's all about predictability. But it comes with a trade-off, a big one. If you mismanage that capacity, or if your application suddenly requires 200 requests per second and you only provision for 100, you can hit a capacity bottleneck that is far, far worse than just hitting standard quota limits.
And the documentation calls this out specifically, doesn't it?
It does. It says load testing is explicitly required for applications using provisioned throughput.
So why the mandatory load testing? Why is it so critical?
Because you must validate that the guaranteed capacity you're paying for actually meets the demands of your production environment under stress. If you fail to load test, you risk severe performance degradation, where your guaranteed latency just collapses. Or, on the flip side, you might find you over-provisioned and are just wasting money.
So the developer's job shifts. It's not just about managing API keys anymore.
No, not at this level. The need for rigorous load testing implies that capacity is a hard, physical constraint that must be managed proactively. Your focus shifts from managing API access to managing the actual compute capacity the model utilizes. It's a different discipline.
Okay, let's move to the core capability. Forget the infrastructure for a moment. Let's talk pure power. The new generation of Gemini is really defined by its context window, and the scale of this leap is, well, it's genuinely groundbreaking.
It's a paradigm shift. There's no other way to put it. For years, models like the first generation of Gemini, they were limited to context windows around, 32,000 tokens?
Which is about 25 pages of text, give or take.
Right. So if you had a document longer than that, you had to chop it up. You got to get clever with retrieval. Gemini 1.5 Pro just shatters that ceiling. It extends the context window to multiple millions of tokens.
And the testing goes even higher, right?
Testing has specifically demonstrated continued high performance up to 10 million tokens, particularly for tasks like analyzing vast, complex code repositories.
10 million tokens. That scale is just transformative. Our sources highlight just how much of an advantage this is when you compare it to the current state-of-the-art competitors. They typically top out around 128,000 tokens, like GPT-4 Turbo, or maybe 200x for Claude 3.
So we're talking about context lengths that are 50 to 80 times larger. It's not an incremental improvement.
So what does that actually change about the engineering pipeline? What does this mean for me, the developer?
It changes the engineering pipeline entirely, and this is the core implication you have to grasp. Traditionally, if you needed to answer questions from a massive document, say, an entire corporate legal corpus or all of your company's engineering manuals, you were forced to implement retrieval augmented generation, or RAG.
The thing everyone's been building for the last 2 years.
Exactly. This meant building a complex vector database, indexing all your data, writing retrieval algorithms, extracting these tiny relevant chunks, and only passing those chunks to the LLM. Now, with a context window of this size, you can often sidestep that entire complex and, frankly, failure-prone retrieval system.
Wait, let me make sure I understand this. You're saying that the long context 1.5 Pro is consistently beating retrieval augmented methods. That suggests that RAG, which is a massive field of engineering, is potentially becoming obsolete for things like internal knowledge bases.
For certain applications, yes. RAG is being fundamentally challenged. Now, RAG is still great when the data is external or just too massive for even 10 million tokens. But if you have the entire source document and you can fit it in the context window, the model's own internal reasoning over that full, unstructured text often outperforms the fragmented, retrieved chunks from a RAG pipeline.
Okay, but how reliable is the model when you're dealing with that much haystack? We've all seen models forget information when it's buried in the middle of a really long prompt.
A classic problem. The documentation addresses this head-on using the needle in a haystack evaluation. This test is brutal. It involves burying a specific piece of information, the needle, in millions of tokens of distracting text, the haystack.
And how did it do?
The results are rigorous and they're impressive. Both Gemini 1.5 Pro and 1.5 Flash achieve near-perfect recall, greater than 99% retrieval up to multiple millions of tokens. The architecture is designed specifically to not forget information buried in the middle of the input.
And this recall isn't just limited to text, which is a really important multimodal point that I think often goes underappreciated.
Correct. The near-perfect recall applies across text, video, and audio modalities.
Yeah.
This is a critical factor if you're building multimodal agents.
The sources have a great example of this, don't they?
They have a stunning real-world use case to illustrate the scale of this comprehension. Gemini 1.5 Pro was given the entire 1,382-page text of Les Miserables.
A whole book.
The whole book. It clocks in at 732,000 tokens. The prompt then showed the model a simple hand-drawn sketch of a specific scene from the book, and the model was able to accurately locate and identify that scene on page 119 of that massive document. It even referenced the context surrounding that specific moment.
That's not just string retrieval. That's not a keyword search.
No, that is multimodal contextual understanding and recall operating at an unprecedented scale. It's what makes it so reliable for complex document Q&A.
So we have these two incredible models, 1.5 Pro and 1.5 Flash. They both offer this phenomenal context and high recall. So how does a developer decide which one is right for their specific application? What's the core trade-off?
The decision really comes down to a classic triangle.
Yeah.
Reasoning depth versus speed versus cost. Pro is the powerhouse. It's built for deep reasoning and maximal quality output.
More capable than the previous top-tier model?
Oh, yes. Even though it's significantly more efficient to run than previous generations, Gemini 1.5 Pro matches or actually surpasses the older Gemini 1.0 Ultra across the great majority of capabilities and benchmarks.
So if my application involves something like complex synthesis or legal analysis or heavy financial modeling, Pro is the clear choice no matter how efficient the new architecture is.
Absolutely. The proof is in those complex, unstructured tasks. When given the full context of a massive document, the full context Gemini 1.5 Pro provided better answers than retrieval-augmented methods, even RGA using competitive models with 4,000 token chunks, in an overwhelming 78 to 83% of cases.
That's a huge margin.
It is. If your application depends on synthesizing complex relationships across vast unstructured text or code, Pro is the model you pay the premium for. It's that simple.
Okay, then we have Flash, the efficiency king. This is the lighter, faster variant that addresses the need for high-throughput, low-latency applications, right?
Yes. Flash is optimized for speed and serving efficiency. You'd often use it where sub-second latency is critical. Think chatbots, real-time summarization, or initial classification tasks where you need an answer now.
And how much of a quality hit do you take for that speed?
Well, it inevitably falls slightly short of Pro in the heaviest reasoning tasks. You can't defy physics. But Flash still greatly surpasses the older 1.0 Pro model. And notably, Flash actually beats 1.0 Ultra on the majority of vision benchmarks 13 out of 21.
Wait, the light model beats the old heavyweight on vision?
It does, and that demonstrates that this efficiency doesn't mean sacrificing multimodal capability. It proves the new 1.5 architecture provides inherent advantages in handling visual data, even in the light version.
Let's dig into the key performance gains that matter most to builders who are creating these agentic applications. Function calling and multimodal reasoning are foundational here. What do the benchmarks show when comparing the new 1.5 models to the previous 1.0 Pro?
The leap in agent capability is staggering, and it directly addresses that developer pain point of unreliable tool use. For function calling, which is just crucial for building dependable agents, 1.5 Pro showed a massive gain of 72.8% over 1.0 Pro.
A 73% improvement. That indicates vastly improved reliability in deciding when and how to call an external tool.
It's a huge jump in reliability. And Flash, the efficiency model, still achieved an impressive 54.6% gain. So either way, you're getting a much better agent.
Those numbers mean this new generation isn't just a bit faster or a bit smarter, it's fundamentally better at orchestration.
Precisely. And that improvement extends to understanding complex, real-world data that's embedded in documents. For chart and document understanding, 1.5 Pro showed a 63.9% gain.
So think about interpreting financial reports, technical schematics, or flowcharts.
Exactly. The model can now navigate those visually and structurally complex documents with much greater accuracy. Furthermore, in specialized knowledge areas, like science and expert knowledge, the 1.5 models consistently outperform the 1.0 models, delivering 4 to 5% more accurate sentences in their explanations.
So the takeaway is pretty clear.
It's crystal clear.
Yeah.
Regardless of whether you choose Pro for power or Flash for speed, you were getting a massive upgrade in core intelligence, reliability, and agency compared to any of the previous generations.
We've established that this long context window is a massive memory upgrade. It enables better recall, better retrieval. But sometimes these models demonstrate capabilities that go beyond just simple data analysis. And here's where it gets really, really interesting. The Calamine language test.
This is stunning.
It's an absolutely incredible demonstration of true in-context learning.
It is arguably one of the most exciting findings in all of the sources because it hints at a latent capability of these models that we haven't fully understood yet. Calamine is an extremely rare language. It's spoken by fewer than 200 people worldwide.
So there's almost no data for it on the internet. It wouldn't have been in the pre-training data.
Highly unlikely.
Yeah.
So to test the model's ability to acquire a new complex skill from scratch, Gemini 1.5 Pro was provided with the full grammar manual and a bilingual word list for Calamine. Essentially, the exact same study materials you would give to a human language learner.
And what was the result? I assume it wasn't just able to recall a few vocabulary words.
No, far from it. The model learned to translate from English to Calamine at a quality level that was judged to be statistically similar to a human language learner who had studied the exact same materials.
That is unbelievable.
It gets better. On the reverse translation task, from Calamine back to English, Gemini 1.5 Pro achieved a human evaluation score of 5.46 out of 6.0. The human reference translation scored 5.60. The delta is almost negligible.
That's phenomenal. So it's not just retrieving facts from the manual, it's acquiring a functional skill from a single massive input document, a skill it almost certainly did not possess from pre-training alone. So this isn't just about translating obscure languages, is it? What's the practical implication for us as application builders?
This is the core so what. The implication extends far beyond translation. This demonstrates the model's ability to acquire novel, complex skills like interpreting a new proprietary programming language, or understanding a complex set of internal financial models, or following highly specific logistics protocols from a single document dump.
So I can essentially onboard an agent to an entirely new vertical overnight.
Just by providing its complete comprehensive manual in the context window.
Yeah.
The massive context window transforms the model from a simple information retriever into a zero-shot in-context learner. It's capable of integrating sparse, highly specialized information and then applying it to complex generative tasks like coding or complex planning or logistics, all tasks where rapid knowledge acquisition is absolutely paramount.
That learning capability is the engine, but function calling is the steering wheel. It's what turns an LLM into a reliable operational agent. And this directly addresses that developer question of how to move beyond simple Q&A to creating applications that actually interact with the outside world.
Function calling is the absolute core mechanism for that. It allows the model to analyze a user prompt, decide if some external action is necessary, and then suggest a properly formatted function call in the response object, complete with all the right parameters.
And this external action could be anything.
Anything your system can do.
Yeah.
Checking the weather, executing a stock trade, adjusting an entry in a database.
For developers who are working manually, maybe via REST API or in languages that don't have automatic SDK support, they really need to understand the required multi-turn conversation cycle. So let's walk through the 4 steps of manual function calling.
Okay. The manual process is a very precise turn-taking protocol, and it requires you to be vigilant. Step 1 happens outside the model, defining the function declaration.
And this is critical for reliability.
It is everything. You must provide the model with a clear function name, a highly detailed description of what its purpose is, and all of its input parameters. This includes specifying data types. Is it an integer? Is it a string? Giving detailed descriptions of what each parameter does, and listing any required fields.
You want to be as specific as possible.
For maximum accuracy, yes. You should include constraints or enumerations. For instance, specifying that a color parameter must be selected from a fixed list. Daylight, cool, warm. You leave nothing to chance.
Okay, so that's the setup. Then the actual interaction with the model begins. Step 2, calling the model with the prompt and your declarations.
Right. You send the user's request, for example, turn the living room lights to a romantic low setting, and you send it alongside the list of available functions you just defined. The model processes all of that and decides whether to act.
And if it does decide a function is necessary, it suggests it in its response object. That leads to step 3, the external execution.
And this is key. Your application intercepts that suggestion. For example, set light values, level low, tone, warm. Your application then executes the real function call in your backend. It calls a smart home API, or it runs a database query. Critically, the model does not execute the code, your application does.
Right. And then finally, step 4, sending the result back to the model for the user-friendly response.
Exactly. You send the function result, something like lights successfully set to warm and 10% brightness, back to the model in the next turn. The model then uses that new context to generate a final natural language answer for the user, confirming the action. I have dimmed the living room lights to a romantic level for you. This multi-turn, back-and-forth communication is the fundamental workflow for any agent logic.
And we can make this more efficient, can't we, with parallel function calling?
Yes, and this is essential when a single user request requires multiple actions that aren't dependent on each other. So if a user says set up for a party night, the model can immediately suggest calling power disco ball, start music, and dim lights all at once in one single response object.
Instead of forcing the application to wait for each result in sequence.
Right. It makes complex multi-action prompts feel much faster and smoother for the user. It's a huge performance improvement.
Our sources even detail the absolute bleeding edge here. Multimodal function calling. If an agent can process video and text, can it also manage file retrieval as part of its external actions?
Yes, and this is where it gets highly complex. The example we've seen in preview models like Gemini 3 Flash describes a two-turn workflow for these multimodal calls. So if the user asks, show me the green shirt I ordered last month, the model first suggests a function call to an internal getImage tool.
Okay.
The external system executes that call, retrieves the data, and the function response that gets sent back to the model includes not just text data, but a reference to the image file itself.
Okay.
Its URI, its display name. The model then uses this retrieved image data in the final multimodal output that's displayed to the user.
So the agent is actively managing complex file references as part of its operational cycle.
It is. It's another step towards a much more integrated and capable agent.
That manual cycle is powerful, but it sounds like a lot of work. Managing that multi-step conversation, ensuring the histogram is correct. Is there an easier path for developers?
Thankfully, yes. And this is a massive convenience specifically for Python developers, automatic function calling, which is available via the Python SDK. This feature just abstracts away that manual turn-taking entirely.
Okay, so how exactly does the SDK manage that orchestration loop internally?
It simplifies the process by leveraging standard Python conventions. As a developer, you just define your standard Python functions, but you include type hints and precise doc strings. The SDK then automatically converts those Python functions into the required function declarations, the schema for the model.
And it handles the back and forth.
It handles everything. When the model requests the function call, the SDK executes the function locally, sends the result back to the model, and then returns only the final user-facing text response to you. The developer gets the final output without ever having to manage the intermediate JSON or the multi-turn conversational history.
That makes development so much faster for standard agent applications like a weather checker or simple data retrieval. But you mentioned there's a critical nuance, a limitation regarding the Python SDK's automatic approach.
This is a subtle but really important limitation to be aware of. When you use the automatic feature, the Python SDK currently sends the entire doc string of your function as the top-level function description in the schema it generates.
Okay.
The issue is that it does not parse out the specific argument descriptions, like the ones you might define in the arg section of a comprehensive doc string, and put them into the property description slots of the function declaration.
So if my functions have really complex parameters that require granular individual descriptions for the model to use them reliably?
You might still be better off manually defining the schema yourself to get that level of precision, or just making sure your top-level doc string covers the intent of all the parameters fully. It's a trade-off between convenience and control.
And for those developers who are stuck doing the manual work via REST, managing that conversation history must be a nightmare. Our sources mention something called thought signature. What is that, and why is it the single biggest trap for manual users?
The thought signature is essentially a piece of contextual metadata. It's included in the model's turn, and it helps preserve its positional context within a long conversation history. You can think of it as a mechanism to maintain the model's internal state.
And if you mess it up?
If you're manually constructing your API requests and modifying the history, you must handle this signature correctly. If you fail to follow the rules, you can break the model's understanding of the conversation flow, which leads to completely unexpected errors or the model getting stuck in a loop.
So what are the rules, just briefly?
They're very strict. You must always send the thought signature back to the model inside its original part. You can't merge a part containing a signature with one that does not. And you can't combine two parts that both contain signatures. It's complicated.
But there's good news.
There's very good news. The key takeaway here is that if you use the official Google GenAI SDKs, they manage this complex rule set and the thought signature automatically. You don't have to think about this specific complex detail again. Just use the SDK.
Okay, moving from the architecture of the agent to actually crafting the prompt, developers need to know how to control the model's output reliably. Let's talk about the most common parameter adjustment, temperature.
Right. Temperature controls the randomness or the stochasticity and thus the creativity of the model's output. For the specific task of function calling, the guidance is clear and deterministic. Use a low temperature, like 0, if you want reliable function calls.
You want predictability.
You want the model to decide precisely and reliably on the expected function structure and parameters every single time. You do not want it to get creative and hallucinate an extra parameter that doesn't exist.
However, there's a crucial high-stakes warning specifically for the latest models regarding temperature control during reasoning tasks. And this is really counterintuitive for anyone who's been working with LLMs for a while.
This is a vital distinction to make. When you are using Gemini 3 models for complex abstract reasoning tasks, like solving a multi-step math problem or planning a complex logistics chain, the sources strongly recommend you keep the temperature at the default value of 1.0.
So you don't lower it for more predictable reasoning.
You do not. If you try to lower it below 1.0 to force determinism in reasoning, you actually interrupt the model's internal search process. This can lead to severely degraded performance or unexpected behavior, like the model getting stuck repeating itself in a loop.
So low temperature for deterministic actions like function calls, but the default or even a high temperature for complex original reasoning. Why is that internal search process so sensitive to temperature changes in these newest models?
Because complex reasoning requires the model to explore multiple possible solution paths. It needs that degree of freedom, that randomness, to escape local optima and find the best global answer. Lowering the temperature prematurely forces it down a single path, even if that path is suboptimal or leads to a logical dead end.
So determinism in action is good.
But forcing determinism in complex original reasoning is often bad. It can break the model's core intelligence.
And the agent workflow also means that we are constantly hitting those token management issues again, because now we're passing more than just chat history.
That's right.
Yeah.
You have to remember that your function descriptions and their parameters all count towards your input token limit. For instance, a complex set of 10 functions with verbose descriptions can easily consume several thousand tokens before the user even types their first character.
So if I'm hitting limits frequently,
the suggestion is to simplify your descriptions. Make them terse, but still effective. Or break complex tasks down into smaller, more focused function sets to reduce that initial prompt overhead.
And finally, the ethical and safety responsibility. That falls back onto the developer, even if the model is the one suggesting the action.
Absolutely. For any function call that has significant real-world consequences, placing a financial order, changing a critical system setting, executing a trade, you must validate the call with the user before you execute it. The model is a brilliant suggestion and planning engine, but it is not the final authority for high-stakes actions. Always, always build in that final human check.
Okay, our sources make it really clear that building with this new technology requires more than just technical skill. It demands critical thinking around security, safety, and application reliability. Let's start with the hard security problem that plagues all LLMs, prompt injection.
The findings here are stark. and they must inform the defensive strategy for every single developer working in sensitive fields. A study in the sources tested 36 diverse LLMs against various prompt injection attacks that were often focused on manipulating the models to generate keylogger code or bypass their safety instructions, and it revealed a systemic high-risk profile.
What was the success rate for these attacks across this diverse set of models that were tested?
The statistics are worrying. 56% of the tests resulted in successful prompt injections across the 144 total tests that were conducted.
So more than half the time the attack worked.
More than half the time. And even more alarming, 28% of the tested models failed all 4 of the injection tests. This demonstrates that the vulnerability is widespread and it's systemic, regardless of the model's architecture or its specific pre-training data.
If these models are supposed to be highly resistant to these attacks during their internal safety training, why is the success rate still so high in the wild? What's the common mechanism of failure?
The analysis points directly to the mechanism of instruction override failure. LLMs, at their core, are built to follow instructions. Prompt injection works by inserting a conflicting, malicious instruction that the model then prioritizes over its original system prompt or its role definition.
It's a battle of instructions.
It is. And the statistical analysis, using logistic regression and random forest feature analysis, showed a strong correlation between vulnerability and factors like the model's parameters and the LLM type. Essentially, smaller or less robustly guarded models are more susceptible to this instruction override.
So it's not just simple, explicit attacks that are the issue here.
No. In fact, the most sophisticated and successful attacks were the ones that skillfully blended benign requests with malicious instructions, often hiding the malicious intent deeper inside the context. This really highlights the difficulty of creating robust defenses against these subtle, context-aware attacks.
So what's the takeaway for a developer?
The takeaway is that since the LLM's fundamental operation is instruction following, the ability to resist instruction override is a systemic weakness. It demands multi-layered adaptive defense strategies, especially as LLMs get integrated into critical financial or security infrastructure. You have to assume your agents are vulnerable and deploy defensive mechanisms in the application layer around the model's output. You can't just trust the model to defend itself.
Okay, beyond external attacks, developers need to trust that the models themselves are adhering to internal safety and ethical constraints. How do the new 1.5 models stack up in internal evaluations for safety compared to their predecessors?
They show clear, measurable improvements. Regarding representational harms, which measure consistent output quality and bias across different demographic groups, the internal evaluations using the standardized BBQ dataset show that the 1.5 models improved bias scores over the 1.0 Ultra baseline.
And this was across the board.
The improvement was particularly noted in sensitive categories like age and disability status, which suggests that more effort went into ensuring equitable responses across user characteristics.
And what about explicit policy refusals? When is the model trained to just say no?
There are 2 key areas of refusal highlighted in the sources. First, the refusal to generate content that violates policy, specifically defamatory content.
Even if the user tries to trick it.
Yes. Even when the user attempts to frame the request as hypothetical or for research or purely fictional by using these complex adversarial prompts, the model is trained to correctly identify the harmful nature of the content and refuse to generate it. Instead, it'll offer alternative, harmless, or factual information.
And the second area involves multimodal input and preventing the model from drawing unsupported conclusions about people based on insufficient context.
This is a crucial area of responsible AI. The model is trained to refuse ungrounded inferences about people in images. For instance, if you provide a simple headshot of a person and ask, "What religion is this person?" the model should refuse. It should explicitly state that religion cannot be determined from a photo alone.
But what if there is context?
That's the key. If the person in the photo is wearing recognizable religious headwear, the model is trained to use that visible context to provide a qualified answer. The rule is simple. Use only visible, contextual evidence, and refuse to reinforce harmful stereotypes or generate speculative and potentially incorrect personal data.
Okay, finally, let's circle back to deployment quality, specifically for developers who are migrating to newer models. As we established with those retirement dates, migration is inevitable. And shifting model is risky. You need rigorous testing to ensure your application doesn't suddenly degrade.
Migration is detailed in the sources as a comprehensive 7-step process, and it's all built around mitigating risk. To maintain quality, the guidance includes 3 distinct types of tests that are either always required or required under specific circumstances. It's a framework for risk management.
The first test is pretty standard for any software engineering change, right?
Yes, code regression tests are the absolute baseline requirement. You must confirm that your application logic, the wrappers around the API, the data handling pipeline, all of that still functions correctly after you swap out the model. The next two tests are model-specific performance guarantees.
What's the first model-specific test?
You need model performance regression tests offline. This is essential for preventing quality degradation. You assert the output quality based on objective metrics like accuracy or coherence scores or fidelity to your constraints in a dedicated experimentation environment before you expose the new model to live users.
So this test is non-negotiable.
It's non-negotiable for validating that the new model version is at least as good as the old one for your specific use case.
And the third mandatory test. This ties back to the complexity we discussed earlier in segment 1.2 capacity and cost management.
Exactly. Load testing is required if and only if your application uses provisioned throughput. Since provisioned throughput means you have paid for a guaranteed capacity slice, you must conduct rigorous load testing to ensure the new model deployment meets your minimum throughput requirements under maximum load.
And if you fail here?
If you fail here, your application will suffer performance or billing bottlenecks, even with the new model's superior intelligence.
So what if that offline testing isn't enough? What techniques do the sources recommend for online evaluation when the model is actually handling live user traffic?
Right. If the offline tests fall short, or if you need to measure something subjective like user satisfaction or coherence, you move to optional but highly effective online evaluation techniques. These include performing standard A/B tests or utilizing canary deployments.
A canary deployment being where you route a small percentage of traffic to the new model.
Exactly. A small, carefully monitored percentage of live user traffic is routed to the new model version, while the majority of users stay on the stable, old version. You can compare the results in real time.
And for gathering direct user feedback on the quality of the model's output in the wild?
You can integrate features designed to capture explicit feedback, things as simple as thumbs-up-down buttons next to the model outputs. In more advanced or critical scenarios, the sources suggest showing users outputs from both the old and the new model side by side and just asking them to pick their favorite.
And you can do this passively too, I'd imagine.
You can. You can passively measure quality by tracking how often users feel compelled to manually override, edit, or adjust the model's output. That's a strong proxy measure for quality degradation or improvement. These techniques help you confirm that your offline metrics are accurately capturing the real-world user experience before you commit to a full deployment.
Okay, that was a lot to cover.
It was. If we synthesize our findings today, I think the key takeaways for any developer moving into production are pretty clear. First, you have to manage your runway, especially that September 2025 retirement date for the 1.5 models.
Right.
Second, you have a choice between Pro, the deep reasoning powerhouse, and Flash, the speed and efficiency champion. But both provide a massive leap in core intelligence and agent capability.
And function calling is key.
Mastery of that multi-step function calling cycle is absolutely non-negotiable for building reliable agents. And finally, security, particularly guarding against prompt injection and managing the complexity of things like provision throughput, must be an active part of your development lifecycle from day one.
This whole shift in model capability has such immense practical consequences. I mean, we've moved from struggling to fit documents into these tiny little windows to being able to handle entire code repositories or entire multi-thousand-page legal documents in a single prompt.
And that leads to the final provocative thought for you to consider today. The sheer scale of the Gemini 1.5 context window, reaching up to 10 million tokens, doesn't just improve existing RAG pipelines. For many use cases, it fundamentally allows models to bypass them entirely for most massive internal knowledge inputs.
So the whole job changes.
The challenge for developers fundamentally shifts. It's no longer about designing complex retrieval and indexing systems to find a needle in a tiny haystack. Instead, the task becomes mastering the art of in-context reasoning and disambiguation over vast unstructured inputs. It forces us to redefine how we architect agent systems and how we measure true knowledge application. You are now the master of context, not the master of retrieval. Think about that as you architect your next application.